Well, hello everyone. My name is Chiranjeevi, and in this video series, you will be learning the structural design patterns. So, structural design patterns are basically responsible for building simple and efficient class hierarchies and relationships between different classes. So, there are quite a few design patterns in this category, and we will be discussing adapter, bridge, composite, decorator, facade, flyweight, and proxy. We'll go through all these structural design patterns one by one, explaining the problem it is trying to solve and the UML diagram. And we'll also go through a coding example which will explain a real time scenario where we can apply this design pattern. So starting off with the adapter pattern, let's take a look at what is adapter pattern, what is the problem it's trying to solve. We'll also take a UML diagram of adapter pattern as discussed, and we'll take a look at the coding example. So let's get started. Well, adapter is a structural design pattern that allows objects with incompatible interfaces to collaborate. Now, what does this mean? What does this incompatible interface to collaborate mean? This is the main essence of this adapter design pattern. So what adapter pattern basically allows it allows some interfaces which are not incompatible, which we want to reuse. Adapter By using adapter pattern, we can reuse those interfaces without writing extra code. So the way this design pattern works is it converts the interface of a class into another interface which client is expecting. It also lets classes work together that couldn't work otherwise because of the incompatibility of the interface. Let's quickly try to visualize the problem this adapter pattern is trying to solve. Let's imagine a scenario where you have an application in which the client program is talking to a file system, and the way the interface behaves, it is exposes two methods: to read from the file system and to write to the file system. So let's imagine a scenario where you want to support one more file system which also behaves in a similar way, but the interface it is providing is not equal or compatible with the interface the client code is already using. So let's look at the UML diagram first, and then we will try to see what is going on behind the scenes. So this is the UML diagram for the adapter pattern. So as you see, you have a client which is always targeting a object which is of type target, and there is a request method in that object which client is accessing. So let's say you have one more uh, class which has also a similar kind of behavior but not the interface. So that means that the interface it is providing is different from the interface the client is already expecting, in this case, which is request. And the interface which our expected class is providing is a specific request. So you see there is a kind of similarity where this client code can be reused to work with the near adaptee object which we have in this problem. So the way to solve this problem is to add an adapter which implements the interface which client is already targeting to, and have a reference to an adaptee which this adapter will adapt to. So what this adapter will do is take the client request and convert it to the request which this adaptee supports. So let's take our file system example. Let's say your client is writing to a NTFS system which is providing read from the system and write to the system as two interfaces. So this client only knows two things: read from the system and write to the system, and it does not know anything what is going behind the scenes. Let's say you are injecting a NTFS file system which is implementing those methods. Now you want to extend the functionality and you want to add support for, let's say, ext file system, which is basically used in Linux. But the problem here is that those file system does not have these methods. Let's say those file system have completely different sets of interfaces for reading and writing to those systems. So what we can do there is inject an adapter and which will implement the interface the client code is using and give and have a reference to the newer adaptee class, in this case our Linux file system, and we will just delegate the call from the client to the newer specific method of that particular file system. So the way to implement this, we'll just quickly take a look in Java and we'll try to code this. So let's take a look at the coding example. Here I have created a very small example to demonstrate the working of adapter pattern. So what we are doing in this example is we are simulating some birds. So here our client class, this is our client class, which is referencing a target interface. So here, in our case, the target interface is a bird interface. And the only thing this bird interface does is to make sound. So any class which implements this bird interface will have to give a special behavior for this make sound method. So I have created one dummy bird, which is called duck. As you can see, I'll remove these borders. So the make sound method is implemented by this duck class. And let's go to our client class quickly. And as you can see, we are instantiating this duck and we are depending on the interface to actually have the functionality of this client. We're depending on the make sound method. Now, let's say your requirements change and now you want to also include plastic birds or plastic toys, whatever makes sound in your simulator. So you happily go and create a class because plastic toy birds, let's say for some time, don't have this make sound method there in the interface, and instead what they do is squeak. So whenever you squeeze some plastic toys, this is the sound they make. So every plastic toy, bird, or whatever can have their own implementation of their sound. So I have created one more class which is called Winnie the Penguin, which implements the plastic toy bird, and the implementation is it is squeaking. So whenever this squeak method is called, it squeaks. But how can we use this plastic toy bird interface with our bird interface? Because since our client code is strictly dependent on our bird interface, it is tightly coupled to the method it is calling. So to solve this problem, what we saw in the UML diagram is we need to create an adapter class which will implement the target class and have a reference to the adaptee. Let's quickly go in our code. So to demonstrate this, I have already created a bird adapter. And since we are targeting the bird interface, we are implementing the bird. Let me remove that. Okay, so we have implemented the bird interface. And after implementing the bird interface, what we need to do is we need to override the make sound method in the bird interface. So that's what we did. Now the second point says we need to have a reference to an adaptee. So in this case, our adaptee is toy bird. Our toy bird is adapting to our bird interface. So we have a reference to our adaptee. And to instantiate this adaptee, I am taking a reference in the constructor and setting it here. So let's quickly go to our client code and see how we can implement this. So in our client code, when we instantiate the bird object, what we'll do now is again create a bird, which will be our toy bird. And to instantiate with the adapter pattern, what we'll do is we'll create an instantiate of the instance of the bird adapter. And here we will pass a plastic toy bird. So the implementation of our plastic toy bird is inside this Winnie the Penguin class. So we'll pass the Winnie the Penguin class and close the line. Now, if you actually do toy bird dot make sound and actually run this, you'll see that squeaking output is there, which means that whatever was there in the Winnie the Penguin, which implemented the plastic toy bird interface, which was nowhere equal or equivalent to our bird interface, now we can use that. So this is how we implement the adapter pattern. It's a structural design pattern which lets you uh, use those interfaces which don't have compatible exposed methods. So we saw how our client is using the target method and how we can actually create one more adapter using our target and have a reference to our adaptee and actually delegate the call from the target to the adaptee and get the output. So thank you guys for watching my video, and in the next video we'll discuss the bridge pattern. So see you in the next one.